The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. A couple of things I want to talk about. One of you emailed me and said that on the videos, apparently over on the right-hand side, when I write over there, it gets blocked by the pictures that are taken up by all the students. So I'm going to try and avoid that side. If there's something else like that going on, please let me know. Also, it's really important if you have a question or questions that you want me to cover during the Zoom sessions in the morning, please don't email those to me at the last minute. Quite a few of you did that this morning. I need those by about 9 o'clock the morning of, so that I can go in and get everything organized and write it down, because once after about 10 o'clock, I don't look at my emails. I'm just getting ready for class. So I want to answer your questions, but I need them sooner than the last minute, please. Anyway, I do have quite a few requests this morning, so we're going to get right on to those. And let's see here. This first one comes, it's actually back in section 5.7, okay, which is a couple days ago. And the first one is number 11. Again, I want to remind you that even though you all have similar problems, they aren't the same numbers. So if you look at your problem and go, well, that's not the one I have, that's probably true. Anyway, this says, find the product. And we have the quantity d to the fourth power plus 1/8 squared. So the first thing we're going to do is expand that, and we're going to have two factors of d to the fourth power plus 1/8. Plus 1/8, that is. Then we're going to FOIL it together. D to the fourth times d to the fourth is d to the 8th power. D to the fourth times 1/8 would be 1/8 d to the fourth. 1/8 times d to the fourth would be 1/8 times d to the fourth. And 1/8 times 1/8 would be 1/64. Recall that when you multiply fractions, you multiply straight across. Combining like terms, we get d to the 8th plus 1/8 plus 1/8 plus 1/8 would be 2/8 d to the fourth plus 1/64. However, we can take this fraction and reduce it to 1/4 d to the fourth. So our final answer is d to the 8th power plus 1/4 d to the fourth, or you could also write 1/4 d to the fourth as d to the fourth over 4, same thing, plus 1/64. Any questions on that before we go on to another one? All right, we've got one more from 5.7, and this is number, let's see, what was it, 14, okay? It says expand the binomial. So we have p minus 3q, that whole thing cubed. So that's going to give us p minus 3q times p minus 3q times p minus 3q. We're going to multiply two of those factors together, simplify it, get the results, and then take that result times the third factor. So starting off, I get p times p, or p squared, p times minus 3q, which is minus 3pq, minus 3q times p, which is minus 3pq, and then minus 3q times minus 3q would be plus 9q squared, okay? So we've got all of that times that third factor of p minus 3q. But I'm going to take this and simplify it further. So I'm going to get p squared minus 6pq plus 9q squared, and then all of that times p minus 3q. All right, any questions so far? So we'll continue distributing. P squared times P is P cubed. P squared times minus 3Q would be minus 3P squared Q. Notice that within each term, I put the variables in alphabetical order. What that does, it makes it easier to identify like terms. All right, here we've got minus 6PQ times P, which is minus 6P squared Q, minus 6PQ times minus 3Q, which is plus 18PQ squared. And then 9Q squared times P would be plus 9PQ squared. And 9Q squared times minus 3Q would be minus 27Q cubed. All right, let's see, what are like terms? These are like terms and those are like terms. So we've got P cubed minus 9P squared Q plus 27PQ squared minus 27Q cubed. And that would be the final answer. Any questions there? All right, let's see here. Okay. 5.8, part 1, number 9. Okay, so now we've got a problem. This is out of section 5.8, part 1, and this is problem number 9, and it says, divide the polynomial by the monomial. And we've got b squared plus b cubed minus b to the 4th power all over b to the 4th power. When we have a polynomial divided by a monomial, we take each term in the numerator and divide it by the denominator. So we're going to split this up into 3 separate terms, 3 separate fractions. Then we're going to come back and simplify each separate fraction. All right, let's take a look at the first one. B squared over b to the 4th power. So that's going to become b to the top exponent minus the bottom exponent, which is b to the negative 2 power. But writing that using positive exponents, we would get 1 over b squared. Taking a look at the next fraction, we have, let's see here, we'll write that down here, b cubed over b to the 4th, which is b to the 3 minus 4 power, which is b to the negative 1 power, which is 1 over b to the 1, or just 1 over b. So plus 1 over b. Finally, the third term, we've got minus b to the 4th over b to the 4th, which is negative b to the 0, or negative 1. Or you could just say, well, it reduces down to negative 1 or minus 1. So there would be the final answer for that problem. Any questions there before we go on? Okay, let's see here. 4770 and here 5.8 part 1, number 8. Okay, so we're still in section 5.8 part 1. This is number 8. It says divide the polynomial by the monomial. Oh, you know what? I'm looking at the answer. Well, we'll talk about it. We'll do the problem and then talk about the answer and why WebAssign marked it wrong. Okay, so we've got 48x plus 64 all over 8, which becomes 48x over 8 plus 64 over 8. This reduces down to 6x plus 8, which is the answer that WebAssign was looking for. This particular student, they wrote this. So it's like they factored out a 2. I'm curious, I don't expect you to answer if you're there now, but I'm curious, we haven't even covered factoring. That's a Math 95 topic, so we don't even get into that here. But it's this answer, if you distribute the 2, you get this same answer. So it's not really wrong, but they aren't really asking you to pull it apart like that. So I think that's why WebAssign didn't recognize it. Okay, anyway, we're going to go on. Number 9 in that same section. Okay. This is the same problem that I did a bit ago for the other student, I think. Let me make sure here. Let's see. Yeah. It's the same exact numbers as that one. So I'm going to skip this number 9 from this student. Let's take a look at number 10. Okay, that one's different. So we have 18. Sometimes the numbers are the same, sometimes they aren't. 18b to the 10th plus 9b to the 6th minus 45b to the 4th, all divided by 9b squared. Let's see, this is supposed to be to the 10th. So I'm going to take each term in the numerator and divide it by the denominator. Okay, so 18 over 9 reduces down to 2 over 1. B to the 10th over b squared is b to the 8th. So we get 2 b to the 8th as our first term. Hang on here. Let's see here. Then our next term, we've got 9b to the, well, let's see. 9 over 9 reduces to 1 over 1. B to the 6th over b to the 2nd reduces to b to the 4th. So we get plus b to the 4th. And then minus 45 over 9 would be minus 5. B to the 4th over b squared is b squared. So we get that final answer. Any questions there before I go on? Okay. Number 11 in that same assignment. Divide the polynomial by the monomial. Negative 32 x squared y cubed plus 28 xy squared minus 4xy all over negative 4 x squared y squared. Again, polynomial divided by a monomial. We're going to divide each term in the numerator by the denominator. So we get negative 32 x squared y cubed over negative 4 x squared y squared plus 28 xy squared over negative 4 x squared y squared minus 4xy over negative 4x squared y squared. Okay. Now, let's focus on this first term. Negative 32 over negative 4 reduces to 8 over 1. X squared over x squared is either 1 or x to the 0 power, which is still 1. So we get 1 over 1. Y cubed over y squared is y to the 1 power. So we get positive 8y. Any questions there? Let's take a look at the next term. 28 over negative 4 would be negative 7 over 1. X over x squared would be 1 over x, okay? And then y squared over y squared would just be 1. So all that becomes, let's see, what have I got there? -7 over that x, okay? And then 4 over -4 is -1, but we're subtracting a negative, so that's going to be like adding a positive. So we're going to get plus, we've got x over x squared, so that's what, 1 over x, and y over y squared is 1 over y, so I get 1 over xy. Okay, again, if you have like x over x squared, that's like x to the 1 minus 2, which is x to the -1, which is 1 over x, and then the same thing with the y's. So there's the final answer on that problem. Any questions there? And I've got one more to look at, and it might be the same numbers. We'll take a look here and see. Okay. 11. Slightly different numbers. We'll go ahead and do it. Same idea of it. We'll just do this. This is the last one here. So we'll do this one. Okay. It's -24 x squared y cubed plus 72x y squared minus 8xy all over -8x squared y squared. So I'm going to have -24x squared y cubed over -8x squared y squared plus 72xy squared over -8x squared y squared minus 8xy over -8x squared y squared. So you can see it's very, very similar. Main difference is the coefficients. In fact, on your homework, you'll notice on WebAssign, in fact, well, you'll see that there's some red numbers. Those are the ones that are different from one person to the next. The black numbers tend to be the same in each one. Okay, so -24 over -8 reduces down to a +3. X squared over x squared is just 1, and y cubed over y squared is just y. So we get 3y as our first term. Okay. Then we've got 72 over -8, which is -9. The y squared over y squared is 1 over 1, but that x over x squared, so you're going to have a 1 on top and an x on the bottom. So we're going to get -9 over x. And then finally, this last one, 8 over -8 is -1. X over x squared is 1 over x. Y over y squared is 1 over y. Negative times negative, we get +1 over xy. So the answer's very, very similar to the previous one. Okay, so with that, we're going to go on and we're going to take a look at the rest of section 5.8. I'm curious, all of the questions that came in were from the first part. None of them were from the long division part. So I don't know, maybe you didn't have issues with that. I guess we'll find out. Or maybe I should ask, were there any questions that people didn't email me in that you want to look at the moment before we go on? Okay. All right, so let's say we have 5, oops, helps if you could spell, 515 plus 403. Okay, so 515 plus 403, and that's 558, right? Is that okay?
Yes.
You sure?
Wait.
Take another look at it.
Oh,
515.
403.
What are you saying?
It's 403, not 43, right?
What do you mean 43? I wrote 403 right there.
Oh,
Didn't I?
no.
What's wrong with it?
The four's in the tens place instead of the hundreds.
Yeah.
Well, why does that matter?
Changes the number.
Oh, it does?
Uh-huh.
So what's the underlying issue here? Besides Mr. Mayo's being belligerent and confusing everyone.
You have to make sure you have the numbers in the right places.
Placeholder. We started to say, yeah. So it should be like this, right?
Yes.
So that 0 says we've got no tens. It didn't say 400 no tens and 3 ones, but we've just come to recognize that, oh, there's 400s, there's 3, those are ones. So there's got to be a placeholder, a 0 there to take care of that 10 spot, right?
Yeah.
Okay, keep that in mind. All right. Let's say we've got this problem, which is b squared minus 36 divided by b plus 6. Okay, if I wrote that as a fraction, it would look like this. It would be b squared minus 36 over b plus 6. If I wrote it in long division form, it would look like this. B plus 6 and then b squared minus 36, right? So far, so good?
Yeah.
Okay, so let's proceed like we did yesterday. Both our inside binomial and our outside binomial are in descending powers. So we're going to focus on the leading term inside divided by the leading term outside. And we get b squared divided by b, which is what?
One over b.
No.
Oh, it's the opposite.
Yeah, so what is it?
B over 1.
Yeah, or just b, right?
B. Yeah.
Okay, so I'll put that up here. I'll put it up there. Okay, so then I take what? B times b plus 6, right? I'm going to take this times all of that, and that's going to give me b squared plus 6b. So I'm going to write b squared plus 6b, okay?
Mm-hmm.
Then I'm going to subtract that from what's up above, change it to addition of the opposite, and there's a problem. Part of the problem is that this is a 6. It's hard to tell. This is a b. So what's the problem there? You don't see a problem?
Is it that the 6 has a b and the 36 doesn't?
Yeah, so they're not the same. They're not like terms, are they?
No.
They don't fall in the same placeholder. So how can we fix this? Well, let's go back to this and let's write that like this: b plus 6, b squared plus 0 b to the first power minus 36. And I don't really need to put that first power exponent there, but I just wanted to emphasize. So what am I doing? I'm putting a 0 to create a column for the missing powers. I've got, this is b squared, this is b to the first power, and this is just b to the 0 power, or no b at all. Okay. So I haven't changed the value of the problem because I just put a 0b. That doesn't change the overall value. But now I've got a column for the b to the first power. So let's take a look at this problem again and see what happens. Okay, so I'm going to focus on the leading terms. I'm going to get b squared divided by b, which is b. That's going to go right there in the b column. Okay. Then I'm going to take b times b plus 6, and I'm going to get b squared plus 6b. It lines up with that 0b column that I created. So now things work out nicely. I'm going to subtract that quantity from what's up above. I'm going to change it to addition of the opposite and add up the columns. B squared plus negative b squared is 0. 0b plus negative 6b is negative 6b. And then bring down the next term, minus 36. Okay, so are you seeing what I did there? I put a 0 in just to create a column for the b to the first power terms. So now, leading term divided by leading term, negative 6b divided by b is negative 6 or minus 6. Minus 6 times b plus 6, negative 6b minus 36, negative 6b minus 36. Subtract that from what's up above, change it to addition of the opposite, 0 remainder. So there's the final answer. Okay with that? Any questions there? Okay, let's take a look at another problem. Here we go. X cubed minus 8 divided by x minus 2. So outside, I'm going to have x minus 2. Inside, I'm going to have x cubed plus 0x squared plus 0x minus 8. What have I done? I've created columns for all the missing terms. Okay, any questions there? All right, leading term inside divided by leading term outside. X cubed divided by x is x squared. Then we take the x squared times the outside x minus 2, distributing, we get x cubed minus 2x squared. So we get x cubed minus 2x squared. Okay, we're going to subtract that quantity from what's up above. We're going to change it to addition of the opposite. X cubed plus negative x cubed is no x cubed at all. 0x squared plus 2x squared is 2x squared. Bring down the next term. It's just 0x, but I'm still going to bring it down. Okay. Focus on the leading term inside and the leading term outside. 2x squared divided by x is 2x, so I get plus 2x. I'm going to take the 2x times x minus 2, and I get 2x squared, squared minus 4x. Yes, 2x squared minus 4x. If I'm going too fast, let me know. I can slow down. I'm going to subtract that quantity from what's up above. Distributing the subtraction sign, changing it to addition of the opposite. 2x squared plus negative 2x squared is 0x squared. 0x plus 4x is 4x. And bring down the next term, the minus 8. Start all over. Leading term inside divided by leading term outside. 4x divided by x is 4, so we get plus 4. 4 times the quantity x minus 2 is 4x minus 8. Subtract that from what's up above, change it to addition of the opposite, and I get 0 remainder. So that's my answer. So that means that x cubed minus 8 divided by x minus 2 equals x squared plus 2x plus 4. Okay. Let's check our work. That means this times this should equal that. Let's see if it does. If we take x minus 2 times x squared plus 2x plus 4, we get x cubed plus 2x squared plus 4x minus 2, let's see here, minus 2x squared minus 4x minus 8. I'm trying to avoid writing with error over at the edge like I talked about. Let's see, we've got x cubed, those cancel, minus 8. So it works. Any questions? All right, let's look at some more problems. Let's see here. That one. How about this one? 3 plus 4x divided into 3 minus 5x squared minus 2x plus 4x cubed. Does this problem have any missing powers?
If by missing powers you mean it's out of order, yes.
No, no, that's not what I mean. Does it have any missing powers?
No.
Okay, but Abel, is it out of order? Yes.
Of course.
Yes. Okay, but there's no missing powers, so we don't have to fill in any 0x columns or whatever. So what we want is on the outside, it's going to be what? 4x plus 3. And on the inside, it's going to be 4x cubed minus 5x squared minus 2x plus 3. I just wanted to emphasize those are different ideas, missing powers versus descending powers. Okay, so now we're going to take the leading term inside divided by the leading term outside. 4x cubed divided by 4x is x squared. We're going to take x squared times 4x plus 3 and get 4x cubed plus 3x squared. Write that over here. We're going to subtract that quantity from what's up above. We're going to distribute the subtraction, changing it to addition of the opposite. 4x cubed plus negative 4x cubed is 0x cubed. Negative 5x squared plus negative 3x squared is negative 8x squared. Be careful, adding two negatives, you still get a negative. Bring down the next term, minus 2x, and continue this process. Leading term inside divided by leading term outside. Negative 8x squared divided by 4x is minus 2x. Minus 2x or negative 2x times 4x plus 3 is negative 8x squared minus 6x. Negative 8x squared minus 6x. We're going to subtract that quantity from what's up above, change it to addition of the opposite, add up the columns. Negative 8x squared plus 8x squared is 0. Negative 2x plus 6x is 4x. Bring down the next term. Leading term inside divided by leading term outside. 4x divided by 4x is 1. 1 times 4x plus 3 is 4x plus 3. Subtract that from what's up above. Change it to addition of the opposite and we get 0 remainder. So there's the answer. Any questions there? Okay, let's see here. How about...
Before you move on, I had a question on part 2 of 5.8 that I'm having trouble with on number 9.
So you're talking about tonight's assignment?
Yes.
Yeah, okay. I want to focus on the getting people through everything we've got here. And then if we have extra time, we can do that. But I'm not going to do tonight's assignment during today's class unless there's time. Okay.
Okay.
Hold that thought. We'll see. I'm just going to do a couple more. And then if we still have time, we'll take a look at that if you want. All right. How about this one? 10n minus 6 over n. What do we do with this?
Wouldn't we divide n from both 10n and 6?
So what should I write next?
You have to write n divided by 10 n minus 6.
Say that again. Oh, tell me what to write.
Divided by 10 n minus 6.
Divided by 10 and minus 6?
N.
So n divided by 10n minus 6?
Yeah.
Not quite. Keep working on it. How do you say, I'm trying to get you to say correctly what I should write here.
I don't know how to say it correctly, but
Okay, we're going to take 10n divided by n minus 6 divided by n. Okay, this down here, that's just the reciprocal of what's actually going on. So we're going to take each term, we're going to take 10n divided by n and minus 6 divided by n. Do you see that?
yeah.
Okay, now we'll go back and reduce it, and we're going to get 10 minus 6 over n. There's nothing we can do with that term. Okay. So that takes us back to the earlier stuff. Be careful, because what will have happen, people will take this kind of problem and they'll set it up this way. And sometimes it works out nicely and sometimes it's a mess. So if you're dividing by a monomial, you want to split it up into separate terms. It's only when you're dividing by a polynomial, 2 terms or more, that you use the long division process, okay? So I want to make sure that you can distinguish between those two. All right, one more here. 21 a to the 30th power, b to the 15th power, over 14 a to the 40th power, b to the 12th power. So here we just have a monomial divided by a monomial. We're going to just simplify it. I can divide 21 and 14 both by 7 and get a 3 on top and a 2 on the bottom. If I take a to the 30th over a to the 40th, that becomes a to the negative 10th, which is 1 over a to the 10th. In other words, this becomes a 1, and this becomes a to the 10th. Okay. And then b to the 15th over b to the 12th becomes b cubed. So up on top, I've got 3 times 1 times b cubed. And on the bottom, I've got 2a to the 10th. Okay. We all right with that? All right. Was it Annabelle that had a question about tonight's homework?
Yeah, it was on
Okay. Just
9.
tell me what it is.
It's negative 4 f to the 4th power plus 6 and divided by 2f to the 3rd power.
So it's just that.
Yeah.
Okay. So we have a polynomial divided by a monomial. So we're going to take each term in the numerator and divide it by the denominator. Okay. Now, this first term, negative 4 divided by 2 is negative 2 over 1. X to the 4th over x to the 3rd would be x to the 1 power. So I have negative 2x. Second term, 6 over 2 is 3 over 1. X cubed is on the bottom. It's got a positive exponent. So there it is, and we're done.
Thank you.
All right, anything else? So a reminder, tonight you've got section 5.8, part 2, as well as the chapter review, okay? Tomorrow, Friday, during class, we will review for the test that's on Monday. On Monday, there will be no Zoom meeting class. You just take your test Monday and finish it by Monday, 11:59 p.m. There's still some confusion amongst people in terms of what I want you to do in terms of showing your work on a test, okay? So I don't want you to take time to try and write all of the work on WebAssign, because that takes a lot of time trying to type it in using all the correct keys and everything. Work out your problems on scratch paper, okay? Put your answers in WebAssign. If the answer is correct, great. If the answer is wrong, if you want me to consider the problem for partial credit, submit the work by taking a picture, scanning your work, submit that to me by email. Now, here's what people have been doing. They've been going back and reworking the problem until they got the right answer. And I don't even look at that. That's not what I'm asking for. I want to see the work that you did that led to the wrong answer you submitted. So I can see, okay, did they have some idea of what's going on? Okay, and you need to submit that right away when you're done with your test. Are there any questions about that? Okay, all righty. We'll call it a day, and I will see you all tomorrow.
All right, thank you.
The